Our next example is negative 1 and 2/3 over pi plus e over pi. Well, what is pi? Well, first of all, pi is not an integer. Furthermore, it is not a fraction. It is what is called irrational. No matter what the fraction is, it would not be equal to pi. Well, what is the value of pi? Well, pi is approximately 3.14159. Now, how can I visualize pi being in the denominator? How can I see that? In this case, I'm going to be using a circle to represent 1. To have pi in the denominator, I would simply need pi pieces to make up the circle. And we have 1 piece, 2 pieces, 3 pieces, and pi pieces. I would like to note that this tiny piece is not 1 over pi. It is more like the leftover. It is not even a whole piece. It is more like approximately 0.14159 of a whole piece. Now let's get negative 1 and 2/3 over pi. Well, what is negative 1 and 2/3? What is its approximate value? Well, first of all, positive 1 and 2/3 is about positive 1.666667. How do I know this? Well, if I were to solve 2 divided by 3 using long division, which would be 2/3, I would get 0.66666666 going on forever and ever. Generally, when you give an approximate answer using decimals, you round off the last digit, and that's why the last digit in this case is 7. Now, if I were to take the negative of both sides, I would find that negative 1 and 2/3 is approximately negative 1.666667. So I need that many over pi. Well, here I have negative 1 over pi. So I need a little bit more, negative 2 over pi. Well, that was too much. So what I'm going to do is I'm going to cut this up into 2 pieces, one of which would be 2/3 of this piece, so that I can have negative 1 and 2/3 over pi. So now I have negative 1 and 2/3 over pi, because in this case, red represents negative. Let's now get e over pi. Well, what is e? Well, e is another irrational number. It cannot be written as a fraction, and its value is approximately 2.71828. So let's get that many 1 over pi's. Well, here is 1 over pi, 2 over pi, so I need a little bit more, 3 over pi. Well, that was too much. So what I'm going to do is I'm going to cut up this piece into 2 parts, one of which would be approximately 0.71828 of this piece. So let's go and do that. So now I have negative 1 and 2/3 over pi and positive e over pi. Let's now solve this problem. So here I have negative 1 over pi, and here I have positive 1 over pi. If I add them together, I'll get 0, so I can just remove them from the scene. And I'm left with this, but I'm not finished yet, because some of the positive can cancel out the remaining negative. However, I cannot just take this piece and let them cancel each other out. This one is approximately positive 0.71828 over pi, and this one's approximately negative 0.6667 over pi. In other words, there's a little bit more positive here than there is negative here. So what I'm going to do is I'm going to cut up this piece into 2 parts, one of which would be approximately negative 0.6667 over pi, and the other would be the leftover. Well, let's go and do that. So now we can take this piece that's approximately negative 0.66667 over pi, and this piece that's approximately positive 0.66667 over pi, add them together, get 0, and remove them from the scene. And what we're left with is 1 over pi and a little bit more over pi. In fact, we're left with approximately positive 1.0516 over pi. Also to note is that negative 1 2/3 plus e is approximately positive 1.0516. Therefore, we can know that negative 1 2/3 over pi plus e over pi is equal to negative 1 2/3 plus e over pi. It makes sense that you add the numerators but keep the denominators the same, because how we would have solved negative 1 2/3 plus e is a lot similar to how we solved this example. However, everything was over pi. So therefore, you add the numerators but keep the denominators the same in this example. The next video in this set of videos includes 2 parts. One is part 8, when you include a numerator of 0, and the other is part 9, when you include a denominator of 0. If you wish, feel free to click on the link here below.